starting going over your Math 5, quiz number 7, Chapter 4, Section 1 to 4.3. This was taken on November 27, 2018. Show all the work in the space provided, and box your answers. Using the letters in question number 2, so these are the letters E, I, G, and F, you're going to go ahead and match the following by putting one letter per blank. So I know there's 4 letters but only 3 blanks, and so you have a higher probability of getting the question right. Standard form, I'm going to look for one that has no parentheses. That would be this one. That would be F. Intercept or factored form, that's going to be 2 sets of parentheses. That's the letter E. Vertex form has only 1 set of parentheses to the power of 2, so your choices are I or G. So if you have one of these letters, then you will get full credit. You don't need both, because I only said 1 letter per blank. Question number 2, match the following by putting 1 letter underneath the graph. 1 equation will not be used. Let's start with the standard form. My A value is positive, so I know my graph's going to open up. And I have a y-intercept, the C value, so ax squared plus bx plus c. The A value is positive, so it's going to open up, and it has a y-intercept of -1. This is not crossing through -1 here. This one does, and this one's opening down, so you can put F here. Let's go ahead and go to the one that has both 2 sets of parentheses. This one is called the factored form. This one is standard. And in factored form, it is the formula A times x minus p and x minus r, or you can also call that like R1 and R2 or something like that. It doesn't matter what letter it is. And then here, you're going to recognize that one of your x-intercepts is 1, and one of your x-intercepts is 5. And your A value is positive, so it's going to open up. So here's a graph opening up. This one's opening down, and it has 1 and 5. So that would be choice E. Now I'm left with these 2 choices here. Notice how both of those have plus signs, and in vertex form, ax minus h squared plus k. So negative x minus -2 squared minus 4. And you can also use your finger, so you cover it up, so the x and the minus sign, so your h value is equal to a -2. And your k value is -4. So -2, -4, and this one says opens down. This one here is counting by 2s. I know that because after 2 boxes it's 4, so 4 divided by 2 is 2. So I'm looking for -2, left 2, down 4. And that one does match. So the answer is I. And you're going to know something that I like to actually go through all the multiple choice questions and make sure that I know that it is not the right one. So here, I'm going to also write vertex form. And this one will be x minus -4. So that means my h value, again, not including the first negative sign, would be -4 and -2. Notice how this one does not go left 4, then down 2. So G is not being picked. Question number 3. Describe the transformation of f of x given f of x plus 1 minus 2. So in the transformations, you're looking for these letters, and the letters here are A, F, B times x minus c plus d. This d value here tells you if it goes up or down, so this one is actually down 2 units. So this one has down 1 unit, so it can't be J, and then F can't be that one. Now pay attention, the C value here is x minus -1. I changed the plus sign to a minus -1 so that you can see that the C value is -1. Why do you need to know a C value that is -1? That means it is going left 1 unit. Left 1 unit would be letter H. I also have a silly phrase, add to X, go west. And this phrase works because of the directionals, north, south, east, west. West means going left 2 units. Question number 4. Identify the vertex of the graph. Then tell whether it's a minimum or maximum. The vertex is a point where it actually changes from decreasing to increasing, from down to up or up to down. And in this case, there's my vertex. Well, if you're on a skate ramp, it's the lowest point, so that would be a minimum. So 0, 0, it's not a maximum. It is a minimum, and you're at 0, 0, so that would be choice D. Question number 5, circle the correct answer. Which function is not a quadratic? So quadratic, we've been working on, has anything to the power of 2. So if you multiply this, you use FOIL or the box, you'll eventually get x. So if you want to do that correctly, that would have been x minus 1, x minus 2. And then you're using those boxes, x squared, negative 2x, negative 1x, and a positive 2. So just notice that it has a power of 2. So it's saying which one is not quadratic. This is quadratic, so I'm not picking this one. Power of 2, so it is quadratic. This one is written just in a funny form, so you can have negative x squared plus 3x. So it's still power of 2. It is a quadratic. I'm looking for one that's not quadratic. My answer is I, and let me show you why I is the correct answer, why it's not quadratic. If you distribute this x here, you'll get x squared minus 3x. And then what happens is that these two terms here cancel. They equal 0 because it's a positive 1 and then a negative 1. And you're just left with y equals negative 3x. And this one is to the first power. This is actually linear. Let me get question number 6 because it was cut off. Alright, so question number 6 says, use the given information to determine the most efficient form you can use to write the quadratic function. You're given the points 1, 0, 4, 23, and 7, 0. This is directly taken from the packets we did in class. And kind of give you some graph paper to kind of give yourself a visual. If this was like, say, 7, 0, and 1, 0, you'll recognize that these are called x-intercepts because they cross the x-axis. Anything with the x-intercepts is best used for factored form. Because factored form is a times x minus r1, x minus r2, and the r values are the roots, which are another names that crosses the x-axis. 423 would be something like this, and then your graph, if you wanted to, would just be. So if you ever wanted to actually write the equation, this would be your r1, and this would be your r2, and then up here, this 423 would be your x1 and your y1 values that you can put into this equation. So it's not asking you to actually write the equation, but which one's the most efficient form. The answer would be factored form. Let's count up how many points. So 2, 6, 6, 2, 2, 2, and 2. So that would give me 2, 4, 6, 8, 14, 22 points on the front side. Back side. Directly taken from your packets. Circle the correct answer. Choose the term that identifies the effects of the graph. It's talking about a vertical. Vertical here you have is the number in front. The number in front tells you that if it is bigger than 1 or equals to 1, that is called a vertical stretch. And if the number is between 0 and 1, then it's a vertical compression. Which of the quadratic functions has the narrowest graph? Well, narrowest, thinner graph means I need numbers that are greater than 1. Okay, so if it's greater than 1, then we can use that. So this is not greater than 1, and this is not greater than 1. So your choices are 1/7 and 1/3. And you can also put this into decimals. 1 divided by 7 equals 0.143x squared. And this one is just 1 divided by 3 is going to be 0.33x squared. Okay, why did I point that out? So if you drew a graph, and this one is the green, this one has a wider graph because it's like 0.143 interest. It's going to grow your money slower. And this one has a bigger number, 0.33 is higher, and that's actually going to grow your graph faster, so that's going to be more narrow, so the answer is C. And then if you actually graphed this, so I'm just going to type in all of the graphs there. So the pink, let's see, looking at our graphs, which one has the skinniest one? That was incorrect. Try that again. The pink graph is going to have the skinniest one because narrowest is I'm looking for numbers that are bigger than 1. So not those. Try that again. It has to be one of these, either A or D, and this one will make your money go faster. So your choice is letter D as your answer. Question number 9. Make sure to show all your work and box your answers. Given f of x equals x squared, so these is your reference points. If you put in 0 for x, 0 squared is 0. If you put in 1 for x, you get 1 squared. My output is 1. If you put in 2, 2 squared is 4, and we've been doing this for a long time, right? So there I have in, let's do a lighter color, yellow. Tells you to graph these. So I have 0, 0, 1, 1, and then right 2, up 4. So my graph's going to look something like this. Let's get those little points on there. And then symmetrical just basically means instead of going right 1, up 1, you're going to go left 1, up 1. And instead of going right 2, up 4, you're going to go left 2, up 4. And then my parent function is going to look something like this. And remember, symmetrical points comes from using a mirror. So let's see if I can get that on the screen here. And there you can see that. Okay. Now, what do I do with the corresponding points? Well, you just basically take your values, 0, and you put it into our function. You can do a couple of things. You can create a rule. So this is a rule. This is one way of doing the problem. And in your rule, I'm going to show you guys my foldable. And in our rule, you have here that anything inside the parentheses but to the right is your C value. And the C value, what you're going to do is you just add C, or in this case you're going to add 2 to your X values. And then your D value, which is on the outside there, you're going to add that to your Y value, so that would be a minus 4. So adding to X goes left, so essentially what's happening here, you're going left 2, down 1. And you'll see that as after we graph it. So I take my X value of 0, and you're going to put, you're going to add 2 to 0, and then subtract 1 from your Y value, so that would be negative 1. You're going to add 2 to your X values, so 1 plus 2 is 3, and 1 minus 1 is 0. And then 2, 4, so 2 is my X value, so add 2, so that gives me 4. And then 4 minus 1 is 3. Let's graph this and see what my graph looks like. 2, negative 1. Write 2, down 1. 3, 0. So write 3, 0. And then 4, 3. And then here, what I'm going to do is I'm going to do some symmetrical points. So my symmetrical points are going to be here, and then now left 2, down 4. So let's go ahead and graph that. And you'll recognize that my graph's going to look something like this. Pink. So in pink, this is my h of x graph. And then I want you to see that even the rule kind of just shifted all the points. So if you had the 5 points here, you can just shifted it. Look, what happened? Huh. My graph's wrong. Because I recognize it should have been left 2. And if you go left 2, that should have been a minus 2. And the reason why, I know why. This is written as x minus negative 2. Does that make sense? I made a mistake. Let's try that again. So my vertex should have been actually negative 2, negative 1. So left 2, down 1. And I kind of knew that once I wanted to shift those points. So let's change the colors. So 0 minus 2 gives us a negative 2. 1 minus 2 gives me a negative 1. And 2 minus 2 gives me 0. So negative 2, 1. Negative 1, 0. And 0, 3. And then left 1, left 2, up 4. That's my graph. Now in blue, which is the correct one. So our correct graph should be in blue, not the pink. And then you'll recognize that from the origin, you are going left 2, 1, 2, and then down 1. Same thing with this point. We should be going left 2, 1, 2, down. No, the yellow one, dot. Left 2, 1, 2, down 1. And that was what I was supposed to go through, the blue graph. So hopefully you can see it through the rule and through the visual of what it's supposed to have. Question number 8, convert each quadratic function in factored form to standard form. So standard form basically means no parentheses. And then you're just going to use, I would just use the box method. Same thing as FOIL. You're going to multiply, and then you're going to add. This is x plus 3. You're going to multiply 2x squared, 9x, 6x, and 27. So then I just combine like terms. I get 2x squared plus 15x plus 27 is my correct answer. Question number 9. Fill in the blank squares so that each row and each column contain all the digits 1 to 4. Numbers in the cages may repeat as long as they are not in the same row or column. I'm going to look for the freebies. It's the numbers without any math operations. So I have a 3 here. 2 numbers that multiply to be 6 has to be 2 and 3 or 3 and 2. So I'm going to try something like this. Two numbers that add up to 4 cannot be 2 and 2, and can't be a 3 here, so this will be a 3 and this will be a 1. I'm going to try putting a 3 here, and the reason why I can do that is because this row has a 3, has a 3 here, has a 3 here, so it's missing 1 right there. And then two other numbers, so 8 minus 3 is 5. 5 has to come from 2 and 3 or 4 and 1. Here I'm going to take a guess, 4 and 1. Two numbers that divide to be 2, that'll be 4 and 2. I have a 2 here, so I'll put a 4 and then 2. Let's see if this one works. Two numbers divided by 2, it could be 1 and 2. That's okay, because my numbers don't repeat, and the missing number is 4. Two numbers that subtract to be 3 will have to be 4 and 1, and that matches. Oh, got a mistake right there. Let's see if the rest of it works. Missing number here is 1. No bueno. Well, I could put 2 here and a 4 here. I think that matches. Let's try this one. Switching these, 2 and 3 maybe. Well, why I put a 2 here? That has to be. So I'll switch these two. 4 and 2. Let's keep the 3 and 2. So if I switch these, this would be the 4, and this would be the 1. Okay, that matches. No repeating numbers, no repeating numbers, no repeating numbers. And I think that works. So here it's either 4 points or 1 point. And the last problem took exactly from your last quiz. Analyze each graph, then circle the function which the model could model the graph. Describe the reasoning used to either eliminate or choose each graph. So we've already done this, and I left an empty graph so you can draw one. So I'm going to write this as 2 times x minus minus 1 and x minus negative 4. And the reason why I changed the plus sign to be 2 negatives is so that I can have vertex form, which I'm going to write right below it. 8x minus p x minus r. That means my a value is 2, and the graph opens up from there. And then I have a p value that's negative 1, so an x-intercept that is at negative 1, 0. So here's negative 1. And this one, x-intercept that is at negative 4, 0. But this one tells me to open up. So now, this is my graph, the example. Now, describe the reason you chose to either eliminate it. So we're going to eliminate it because the concavity does not match. Does not match. My concavity here is that this one opens up and this one opens down. So I'm actually going to reject this and not circle it. The x-intercepts match. So let's count the points for this problem. This side of the quiz, 2 points each. So this is a 4, multiple choice 2, 4, and then each of these were 4, so that's 12, 22, and then your quiz is going to be out of 44. Hope this was helpful for you to do your quiz corrections.